You know what really separates beginner coders from professionals? It's not knowing 10 programming languages or 10 programming frameworks. It's the ability to take a coding problem, no matter how overwhelming, and break it into clear, manageable steps that you can actually solve. In a world with AI, where AI is already writing code, we don't need more humans who can write code. We need humans who can actually think through coding problems and provide human solutions to human problems. That's still on us as developers, and that's what employers value the most. In this video, I'm going to show you how I go about breaking down coding problems in my companies, and these principles have really helped me throughout the years in my professional software career. And so if you're feeling frustrated or stuck in your coding problems, hopefully you can apply these principles to your coding problem today. Alright, so the first step for every coding problem is you need to make sure you truly understand the problem and what the customer wants. And what I mean by customer is maybe it's your actual customer or your client or your supervisor or your team. You really need to understand what they actually want and make sure you understand that very clearly, because a lot of times a lot of misunderstandings can happen, especially in an interview. I've seen so many times where the interviewer would ask a question, or sometimes I was being asked a question in an interview, and then I would automatically assume that I knew what the problem was. But when I assume and make these kinds of assumptions and don't really understand what the problem is, then I come up with a solution that's overly complicated. But a lot of times that can be simplified or that can be clarified if you can first understand what the problem truly is, and then you can realize, oh, this solution doesn't really have to be that complicated. Okay, let's go through a simple example. This is a common interview question called FizzBuzz. And basically what it's asking is, given an integer n, return a string array answer 1 to indexed, where answer I equals FizzBuzz if I is divisible by 3 and 5, answer I equals Fizz if I is divisible by 3, answer I equals Buzz if I is divisible by 5, and answer I is equal to I as a string if none of the above conditions are true. So here's some examples, and this is something that can really help you for understanding the problem. So for these examples, the input is a number, an integer. So we have n equal to 3. You're setting the value of n is equal to 5, n is equal to 15. Then the output is an array, and so that's really key. You need to understand that the customer wants the output to be an array. So it has to be an array, and the array size is dependent on the number that's given in the input. So here we're understanding that this one is 3 elements here in this array, 5 elements in this array, 15 elements in this array, and the way that the array works is you have 1, 2, and then Fizz, and it's Fizz because, as it says here, it will be Fizz if I is divisible by 3. And so one thing that can mess you up is you don't realize that this array is actually an array of strings. So you can see here there's quotes here, quote for 1, then quote 2, quotes for 1, 2, and quotes for 4. But you can also see here that the customer wants a string array. So that's the output. And I know that if I was a younger programmer, I would easily overlook this and then make the problem a lot more complicated. But once we know that the output is going to be a string array, that simplifies our solution a lot more. So based on our understanding of the input and output, we can go ahead and create our function. So we have this function FizzBuzz, and then we want it to return an array of strings. So that's why we have to do char star star. And then there's the input, which is an integer n. And then we also have to return the size of the array that we're returning. For this problem, n is always going to be equal to the return size because we're providing the size of the array in this parameter here. But LeetCode just wants us to follow the consistent pattern on how to return an array. So every time in C, when we return an array of strings or an array in general, we also have to return the size of the array through this parameter here. All right, so now we know what the input is like, what the output is like. And so this leads into the second step, and that is to start breaking down the coding problem into different parts. And this itself is a big module. This is a FizzBuzz module with an input and an output. And you'll notice that when you're building programs, building applications, there are a lot of different modules in your application. Everyone is going to have an input, do some processing, and then have an output. And so we can even think of this coding problem, even though we have one big module here, we can break down this module into smaller modules. So naturally, the next step here is, now that we have this input n, we need to initialize, or we need to start creating the array. We need to create the array that is going to hold all of the strings. So that's going to be the next module. Okay, so we're going to use malloc here to allocate our array. And this is the only way that we can allocate the array, because the user is going to tell us how big the array is. So we have to dynamically allocate our array. So we have to use malloc. And so now we have this as an input, and then our output here is going to be a result. So this is why I'm talking about thinking modularly. So we have another module here called malloc, or another function here. It's going to give us another output, and this output is an array with the size of n. So we have this array here, the result. Now what we can do is we can create a for loop that will go through all of the elements of this array, and we know this array is a string array of size n. So we can create a for loop here and be able to iterate through the whole array and fill up the array with this for loop. Alright, so we have a for loop here. We're going to index starting from 1, because if we have n equal to 1, then we're only going to have one element in the array. So we're going to start with 1 here, and we're going to iterate all the way up to n. So if n is equal to 3, we're going to go from 1 to 3, and then we're going to fill up our array. But before we do that, I want to make sure that we are going to return the result. So let's go ahead and return the result here. And we also need to return the size, right? So we need to return the size of the array here. Okay, so now we have the for loop here, so we know the magic is going to happen inside this for loop. And what I want to do now is I want to break this problem down into a more simply, not thinking in modular terms. Now we're going to think more in simplicity terms. So how can we make the solution more simple? So let's first look at the general case and then see if there are specific cases. So we have the general case here, and then the special cases are going to be here. So let's go ahead and handle the general case first. So we're going to go here. Alright, so I think this handles the general case. So we have a buffer here of size 12, and it's 12 because we want to have enough characters to be able to hold 32-bit integers. So we're going to have that as 12. Then we're going to have sprintf. We're going to use %d to get the I value, the I int, and then we're going to store it as a string in the buffer. And then we're going to use strdup or strduplicate, and we're going to store this buffer string into result I-1. And we do I-1 because if you look at the example here, you see that it looks like it's one indexed. And so if it's going to be one indexed, we want the first, we're iterating from 1 to n, but if we put in 1 here, we want, when we have I is equal to 1, we want the 1 string to be stored in the first slot, which is the 0 slot. So we have to do 1 minus 1 to get 0, so that we can store the 1 in that 0 slot. Okay, let's go ahead and try running our code so far. And it's going to say wrong answer here because we didn't handle all of the special cases yet, but we just want to check that we're handling the general case correctly first. So we go here and we can see 1, 2, 3, and that's exactly what we want, but here it says Fizz. But we're going to handle the special case later. Let's go ahead and look at case 2. And look, we're doing 1, 2, 3, 4, 5. So that means we're doing what we expect. We're able to just put in the general cases here. And now we have to handle the special cases. So let's go ahead and handle the special cases. Okay, so here I think we've handled the special cases. So if it's divisible by 3 and 5, it's divisible by 15. So if we can do modulo here at 15, and if it's equal to 0, then it's divisible by 3 and 5. And so we can put FizzBuzz here into this slot here. If it's not divisible by 15, we want to check if it's divisible by 3. So if it's divisible by 3, we put Fizz. If it's not divisible by 3, but it is divisible by 5, then we put in Buzz. So I think this will handle the special cases. So let's go ahead and run this one. Okay, so there you go. So we're able to handle the special cases. Now we have Fizz here, and then FizzBuzz, and then the 15 case. So we're handling all of the cases here. But there's another special case that I think we didn't really think about, and that is if n is equal to 0. So if n is equal to 0, we want to return null. Okay, so we put a return null here, but we also have to make sure we're setting return size. So let's go ahead and take this code here and bring it all the way to the top. So let's put it here at the top, so that if in case we return null, we also return size to be 0. So let's go ahead and run this. Okay, so we're still passing all of the test cases. So just to summarize, what we did was we made sure we understand the input and the output, make sure we understand what the coding problem is asking, and then we go ahead and create our function prototype. And usually in LeetCode, they'll just give it for you for free, but you can have more clarity on what you're going to return in your function. And then we go ahead and we break down our coding problem into smaller steps. So we started to think, okay, let's allocate the memory that we need for this array, of this array of strings, and then go ahead and return it. So we return the array at the bottom. And then we have this for loop here, and this for loop is going to do all of the processing. So we do all of the processing, and what we did first is we broke down our problem into the general cases, and then we handled the specific and the special cases and the edge cases later on. So we handled the general case here first, make sure that works, and then once that works, we put in all of the special cases. And so if it's divisible by 3 and 5, return this one, or we store this one in that slot. If it's divisible by 3, put it in that slot. If it's divisible by 5, put it in that slot. So we handle the general cases first, then we do the special cases, and then we also do the edge cases. And one popular edge case is if n is equal to 0. So this is how I would go about breaking down this coding problem. I also want to share a real-world example in my professional software career. So this is not just for coding problems or coding challenges, but also for coding projects. We also have to break down our coding projects into smaller tasks. So for one of my projects in my company, I had to design an Android app where we had these different phones that can operate in a network, in an ad hoc network. And so these phones had to communicate information to each other. And if one phone could reach another phone, but it couldn't reach another phone that was far away, they still had to be able to route traffic through an intermediate phone and be able to share information through this ad hoc network. So I had to come up with an Android app and how I could demo this capability. So it sounds overwhelming at first, but if we break it down into smaller tasks, then it can be more manageable. So the first step is I had to get my phone, and one of the first things I wanted to do is I want to make sure that it can have some sort of network in it and have a USB network where it can connect to a switch and be able to communicate to my computer. So that was the first thing I did. I implemented a network interface so that I can have an IP address and then be able to ping my laptop or my computer, my work computer at that time, and be able to send information, send data from my phone to the computer. So that was the first step. And the second step was be able to have two phones to communicate to each other. So they have them be on the same network, the same subnetwork, and then be able to communicate data to each other, send files to each other. So that was the second step. And then the third step was to be able to have these phones be able to find out and discover one another, and then have them add the nodes that they discovered in a list. So they want to be able to broadcast that they're on the network, and then have them create a list of all of the nodes that are in their network that they can see. And then so I did that with just two phones that were in the same network. And then lastly, now I wanted to see if I can add a third phone, or maybe a fourth phone. Well, we have to make it simple first. So I added a third phone, and then I wanted to see if I can get the second phone to be able to see both of the first and the third, but have the first phone not be able to see the third phone. And I wanted to see if the second phone could tell the first phone that it can see the third phone. And so that was the next step. And then have the first phone know that there is a third phone, but we have to route the traffic through the second phone. So that was ultimately the last step. And then ultimately, once we have all of these routes set up, then I can actually send a file from the first phone to the third phone via the second phone. And then to top it all off, I added a fourth phone, and then I have 2 to be able to see 3, but not be able to see 4. But know that the third phone can actually see the fourth phone. And then so I was able to have them create their ad hoc network, and then have them to be able to communicate which nodes they can see, which ones they cannot see, and then be able to route their traffic that way. So now the first phone knows that there's a fourth phone, but it has to route it through the second and the third phone. And so it's a bunch of these small, easy steps. And once I master the simple steps, then I can add more complexity to my application, to my Android app. And then when I add more complexity to it, I can grow it and make sure that everything's working throughout the process. And so that's how I was able to break down that coding project into smaller bite-sized chunks. So for every coding problem and for every coding project, you want to be able to think high level first, and maybe even write some pseudocode at first. And that's the first most important thing. And even in our day with AI, we can just worry about the implementation later. The most important thing as developers is to know that we understand it in our heads first at a high level. So whether it's the FizzBuzz program or my Android application, we want to think high level first. What are the inputs? What are the outputs? What are the different modules in our program or application? And then we also want to think about the general case. What are the general cases there? Make sure we handle those first. And then we handle the special cases through some if statements or else statements, or some more complex code to handle those special cases. And then in the case of my Android application, we want to handle the most simple tasks first and the most basic tasks first. And then we build on those simple and basic tasks by adding more features. I also want to encourage you that the more coding problems you do, the more coding projects you get involved in, the more solutions that you come up with, you'll start to see a pattern for all of these coding problems. You'll start to see that some coding problems are just flavors or variations of other coding problems. And then you'll start to see a pattern here. It's almost like learning a language. Once you learn how to say something in one way in a certain language, you can start saying different similar things in that same language, but using different vocabulary. But the general grammar structure is still there. And so you start to see these different patterns, and then you can easily identify solutions in the future. All right, like I mentioned earlier, if you're just starting off in your programming journey and you don't know where to start, you can download my 30-day beginner coding challenge. And it's a 30-day guide where I teach you how to build those 4 beginner programming projects. It's really beginner friendly, and I go step by step on how to build each one and go through the tutorials that you need to build each one. So download that in the link in the description. If you want more help or guidance on how to approach a coding problem, you can watch this video here. In that video, I go through another lead code challenge, so you can watch that video here.